Hello everyone. We want to introduce parabolas today. Now parabolas are conic sections whose definition is simply it's the set of points that are equidistant from a fixed point and a fixed line. That fixed point is called the focus. That fixed line is called the directrix. So two of our terms here. You can't actually see them when the parabola is drawn, but they are used to guide the drawing of the parabola. Now, the closest point between those two, this guy right here, is called the vertex, and every parabola basically has a mirror image called the axis of symmetry, which runs right through the vertex. So if I draw xy axes right now, okay, and I use the definition, which is it's the set of points equidistant from the two, then what I want to do is take the point x comma y, let's take our focus, let's call that 0 comma p. The value of p is the distance from the vertex to the focus. It's also the distance from the vertex to the axis of, to the directrix, so that means the directrix would be the line y equals negative p. So if I call that distance there d1, and I call that distance there d2, then d1 must equal d2 for every point on the parabola. So using our simple distance formula, d1 would be x minus 0 squared plus y minus p squared under the root. d2, which is the simple vertical distance, is just y minus negative p. So setting these two equal, the easiest way to solve would be to go ahead and square both of them. So if I square d1, I'll get x squared plus the square of this, which is y squared, minus 2py plus p squared. Here, if I square this, I'll get y squared plus 2py plus p squared. Now notice, very conveniently, the y squareds cancel, the p squareds cancel, and I'm left with x squared minus 2py equals 2py, or x squared equals 4py. Solving for y gives us y equals 1 over 4p times x squared. Now we'd like to take that same parabola and shift it so that the vertex is now at some point, we'll call it h comma k. So if I take my original equation and I do a shift, that simply means I replace y with y minus k, and I replace x with x minus h. Putting the k on the other side gives us y equals 1 over 4p times x minus h quantity squared plus k. Now that form should look very familiar because the way we've always looked at parabolas are anything of the form y equals a squared, x squared plus bx plus c, and then when we put it into the vertex form, if you remember from previous classes, we always wrote it in this form. We now know what a is. A is exactly that quantity right there. And we know that if a is a large number, that the parabola is very skinny, and if a is a small fraction, the parabola is flat. If a is negative, the parabola goes downhill. So basically, the larger p is, the flatter the parabola, the smaller p is, the skinnier the parabola. So we can go from the equation of the parabola and pull out all the relevant information. So let's do a simple example. Let's find an equation of the parabola. Let's say with focus 3 comma 4 and directrix y equals about negative 2. Okay? So the first thing we want to do is find the vertex, because that's 2/3 of the answer. So the vertex is going to be the point that's exactly halfway between these two. So we see the x-coordinate will still be 3, and then the y-coordinate will simply be the average of 4 and negative 2, which would be 1. Okay? Now we know the equation of our parabola will be of the form something times x minus 3 quantity squared plus 1. Now I just need to figure out the 1 over 4p part. So if I go from vertex to focus, You notice there's a difference of exactly 3 units between these y coordinates. That tells us the value of p is 3. So 1 over 4p is 1/12. So the equation of this particular parabola would be right here. Now, given the parabola in this form, we want to find the axis of symmetry, the vertex, the focus, and the directrix. A little more daunting task because it's not in the proper form. Now there's 2 ways I could attack this. I could try to complete the square, which would be a little bit difficult because that lead coefficient is not very friendly, or I can simply start with the axis of symmetry. Now we remember from algebra that the axis of symmetry is the vertical line of the form x equals negative b over 2a, where a, b, and c were the coefficients. So in this case, that would be negative 1 over 2 times negative 1/8. So negative 1 over negative 1/4, that's simply 4. That means that the axis of symmetry is the vertical line x equal 4, so the vertex has an x-coordinate of 4. To find the y-coordinate, I'll simply substitute this back in. So the y value will be negative 1/8 times 4 squared plus 4 plus 5. So that would be negative 2 plus 9, or in this case, looks like 7. Now we know the form of this is going to be negative 1/8 x minus 4 quantity squared plus 7. So we have our vertex. Now we just need the focus and the directrix. The negative here tells us something very important about this parabola. It tells us the parabola is not only opening downwards, but it's also fairly flat, so it's going to have this form. So negative 1/8, which is 1 over 4p, 1 over 4p means that 4p is negative 8, or p is negative 2. P is the amount that I'm going to add to the y-coordinate in order to get to the focus. That means our focus will be 4 and then 7 plus negative 2. The directrix is the line where I'm going to subtract this. So I'm going to have 7 minus negative 2, or 9, and it's this horizontal line.